Hello everyone, let's solve our next math problem. For a real number x, we denote by bracket x the largest integer less than or equal to x. Let n be a natural number. The integral from 0 to n of bracket 2 to the power of x dx equals... Okay, we have a whole bunch of expressions. I'll read them out, but you can see them on the screen. Base 2 log of 2 to the n minus 1 factorial. N times 2 to the n minus the base 2 log of 2 to the n factorial. N times 2 to the n, or the base 2 log of 2 to the n factorial. Okay, so my first instinct here is that even though it's written as an integral, it might just be a sum, because if we're taking the largest integer less than, this thing in brackets, the square bracket, 2 to the x in bracket is the largest integer less than or equal to 2 to the x. And so this function is piecewise constant between integer values of x. Let me write out what the integral itself is. Okay, so I think an easy way to try and figure this out might be to graph this function, plot this function for x between 0 and, I won't do it all the way up to n, but some... oh, wait a minute. Oh, no. No, I'm totally wrong. It's not piecewise constant between integer values of x. It's piecewise constant between, like... Okay, well, I still think plotting the function is still going to be a very good idea. And then we might be able to just geometrically evaluate this integral. So when x is between 0 and 1, this 2 to the x goes from 1 to 2. When x is equal to 2, this thing will be equal to 4. When x is equal to 3, this thing will be equal to 8. But it kind of skips up in between these things at sort of logarithmically along the base. Maybe a change of variables will work here. I think this is correct. I can never remember derivatives of exponentials in a different base. So let me just derive that for now. Okay, yes, I was correct. du is equal to this expression here. So if I use this substitution, this integral, this is equal to the integral, I'll figure out the, when x is equal to 0, u is equal to 1. When x is equal to n, u is equal to 2 to the n. And dx is equal to, so I'll have a 1 over u log 2 du. This doesn't actually look much easier to compute, simply because the integer part divided by the number itself is not, I don't know how to integrate that, at least not an easy way. So maybe in fact a purely geometrical way of doing this is more straightforward. So I should be able to compute easily if I think of these. If I think of the integral as a sum of areas of rectangles. There's one area, and then when I integrate from 1 to 2, there are 2 rectangles here, split like that. When I integrate from 2 to 3, there are 4 rectangles. Yeah, there's 4 rectangles in here, right? There's 2 rectangles there. There should be go 1, 2, 3, 4. But I'm not sure what the easiest of these methods is. I don't think this substitution is going to be nice. Although this is going to be okay, this is 1 over log 2. If I write this as a sum, k goes from 1, let's write it as k goes from 2 to the n, integral k minus 1 to k of u integral part divided by u du. Right, all I've done is I've broken this up into a bunch of I've divided the interval into subintervals where the endpoints are integers. So, I mean, you can work this out, right? If you wrote out this summation for all the values of k, the first integral goes from 1 to 2, the second goes from 2 to 3, then 3 to 4, 4 to 5, and so on, and they all combine, and the upper limit is going to be 2 to the n. I've just divided it. I've divided it to where this this part is constant. Okay. So now I have an integral from k minus 1 to k of, so u, bracket u is the largest integer less than u. So this is going to be k minus 1 times du over u. And this integral we can do easily now because it's just going to be a logarithm. So I have k minus 1 times log of k over k minus 1. And I think, oh, this is not quite a telescoping series. I'm hoping a pattern will arise if I write this out for the first. Like okay, so I've just kind of done this expansion, right? I've taken this k minus 1 and brought it up into the exponent of the logarithm on each of these terms, and then used a law of logarithm. I have a sum of logs, so it's the same as the logarithm of the product. And now I should be able to cancel a whole bunch of terms here, right? I have here I have a 2 to the 1, here I have a 2 to the 2, I have 3 to the 2 and 3 to the 3. So everything in the numerator cancels except for 2 to the n to the power of 2n minus 1. And in the denominator I'll be left with one factor of each of these numbers, right? If I cancel those, I'll have one factor of 2. If I cancel those, I'll have one factor of 3. So this will take me up to 2 to the n minus 1 factorial. So the answer, unless I've made a mistake, is the, and remember I've canceled I've dropped this log 2 here. So all this algebra I did was just for that summation. So this thing should be the base 2 log of this messy thing divided by 2 to the n minus 1 factorial. But okay, so we should have some more rules of logarithm stuff going on here. I think I might see the answer as one of the available options. So this is very close to one of the available options, except that the exponents should be n, not n minus 1. And so I'm thinking I have an arithmetic mistake or an off by one index type mistake. So what I'm going to do is I'm just going to redo all of my computations from top to bottom. I'm not going to express out loud all my steps and walk through my steps out loud. I'm just going to go through it quickly, see if I can find where I made a mistake. So this is unfortunate because I'm getting the same answer that I had before. Like this, where I have 2 to the n minus 1 in a few places, rather than 2 to the n, but maybe they're actually equivalent. So this is equal to, let me write this as and I even went through the computation, more or less the same sequence of steps, but I used different index convention for my big summations. So this is base 2 log 2 to the n minus 1. Okay, hold on. I'm going to multiply and divide by something in here. 2 to the n factorial divided by 2 to the n. Okay, yeah, so in fact, I didn't need to do all this extra work, I just needed to do some extra simplification. But it's always nice to check your work, I guess. Maybe not in a timed exam like this one, unless you can do so quickly. So I get that the answer is n times 2 to the n minus the base 2 logarithm of 2 to the n factorial, which is one of the options given. It's option B. Yeah, my first instinct on this was a little bit off, but generally, I guess things generally worked out here. Maybe things would be a little bit more straightforward if this were done directly in terms of areas of rectangles, like finding where the function changes value at each of these places. I'm not sure exactly what instinct it was of mine that sort of told me to do this substitution. I mean, I suppose it is in many ways a substitution you might try anyway. I'm not sure. I bet if you did it by the areas of rectangles directly, you would probably still have to evaluate a series that looks like this. So, the actual work wouldn't have been too much different. But yeah, ended up getting this one, I think. If I find a mistake or if I have any more to say, I'll put it down in the description. Thanks for watching.